This study is a differential scanning calorimetry and thermogravimetric analysis of a wood polymer nanocomposite. Wood is famous because it's widely used, renewable, it has good physical and mechanical properties, it has a very aesthetic appearance, and it is environmental, good, and it's not bad for your health. Many studies have been done to replace synthetic plastic materials that are non-renewable and not eco-friendly with wood. The main constituents of wood are tubular fibers or cells that are cemented together. Cellulose and carbon are responsible for its strength, also its linear orientation and high degree of polymerization. When wood is subjected to heat flow, pyrolysis products are formed, and this can increase or reduce heat production. The mechanism of thermal stability property in a wood composite depends on chemicals. Fire retardant chemicals in pyrolysis reactions reduce the effective heat of combustion. To evaluate the effectiveness of thermal property, various methods have been developed. Differential scanning calorimetry and thermogravimetry are simple methods for evaluating the pyrolysis and flame retardants under air or inert gas flow. The present study investigates differential scanning calorimetry and thermogravimetric properties of clay dispersed on styrene coglacital methacrylate wood polymer nanocomposite.
We will use 5 specimens that will be applied in the wood.
Styrene glycidyl methacrylate monolinite nanogly trimethylstearyl ammonium is a catalyst, benzoyl peroxide.
In order to increase the reaction rate by free radical mechanism. Oven-dry specimens were impregnated with 500 milliliters of styrene, a mixture of 500 milliliters of styrene with 10 grams of monolinite, a mixture of 500 milliliters of styrene with glycidyl methacrylate 1:1 ratio, and 10 grams of monolinate. The 4 different solution mixtures were used to impregnate the wood specimens. The wood specimens were then separately placed in an impregnation vacuum chamber of 75 millimeters for 30 minutes and 10 grams of catalyst was added. After that time, the excess of chemicals were wiped off. The specimens were wrapped in aluminum foil and left in an oven for 24 hours at 105 Celsius. In this last step, polymerization takes place.
The infrared analysis just shows us how all the catalysts were added correctly and were absorbed by the wood. In this thermogravimetric analysis, we are able to see how the catalyst actually reduce the total weight percentage of the raw wood. Here we can see that the heaviest of them all was the raw wood, and the styrene clay wood polymer nanocomposite was the lowest weight percentage. And on the DCS scan, we are able to determine that exothermic peaks around 430 degrees Celsius were observed for the ST clay WNC, ST and GMA WPC, and the ST GMA WPC components. From this experiment, we can conclude that the wood was able to absorb the clay dispersed styrene coglacidyl methacrylate, which is proved by the infrared analysis, and that the scientists were able to enhance some of the properties of the wood nanocomposites, as we saw in the TGA and the DCS analysis. And from the paper, we learned from the different types of scanning processes and their different uses. And we believe that all of them are extremely useful, but we found that the most interesting one was the TGA, as it was able to show us the total weight of the composites and with the applied catalyst, which can be very useful for further applications as wanting to reduce the total weight of a component. And we believe the TGA would be an excellent analysis to be able to do that.